right, and you don't need to write this stuff down at first, but I just want to write out this word that I keep saying what the pink list is. So that pink list that you got, these are called polyatomic ions. So if I ever say you need to get your list of polyatomic ions out, I'm talking about the pink list. I printed it on pink paper since that starts with a P and polyatomic starts with a P. These are polyatomic ions. Now poly is a prefix. What does the prefix poly mean? Many. Good. So these are many, and then atomic just means atom. So many atom ions that we're looking at right here. So let's look at one of these on this list. One of them, let's do the second one. I want to save the first one for later. The second one on here, it says nitrate. All right, it says nitrate. You may have heard that word nitrate before, like maybe there's nitrates in some foods or fertilizers or something. So one that's called nitrate. And then we can see the formula for it next door to that. All right, so it puts the formula in parentheses. It's got it as NO3 minus. That means there's a nitrogen, there's 3 oxygens, and then all of these atoms come together to form one ion, and it's got a -1 charge. I know it has a -1 charge because of that minus sign right there. So when you look at these formulas on here, I know they're really small to see there, but I think you can see them. It's important to keep up with which numbers are high up and which numbers are low down. In nitrate, this 3 is down low. That means there's 3 oxygens for every 1 nitrogen, and they're going to be bonded all together there, and they all cluster together. They're going to act like one single ion. When, in this case, it would be a -1 charge. If we could have another one on there, look at one that has a -2 charge on it. Let's look at carbonate. Okay, so go over to the right-hand side. There's some more ions over there. There's one called carbonate. This is here. So the one called carbonate, it's CO3. It's got a 2- charge overall. Then you can really see the difference between the low-down number. The 3 just means there's 3 oxygens for every 1 carbon. And then that 2-, that means the charge of this one is -2. And they tell us the charge next door in that column on the pink list also. So if I were looking at a different compound, if I were looking at sodium carbonate, instead of thinking of it as just the sulfide in there, I can think of CO3. It's really made up of a couple of different elements. But when you think about how these formula units come together, you're just going to think of it like it's one big element with a -2 charge. And in this way, it still takes 2 sodiums to come together with every carbonate. So the formula for this one is going to be NaCO3, 2CO3. And then naming it, you would just name it sodium carbonate. Now, what do you notice that most of these, look at the names. There's a couple of endings that you see for a lot, not all of them, but for a lot of the names. What do a lot of these polyatomic ions end in? 8. Yep, there's a lot that end in ATE, like carbonate. And then what else do they sometimes end in? A lot of them end in ite also. And there's a difference between the 8s and the ites on here. There's usually like a couple of pairs that are like almost like brother and sister or something. For instance, there's nitrate and nitrite. It's going to be really important when you're dealing with these to keep up with just one little letter makes a difference in the chemical formula. All right, so let's look up nitrate one more time. Nitrate, again, next to it, it tells us that it's NO3 with a -1 charge. What's the difference in nitrate and nitrite? Is there any difference in nitrite? Number of oxygens. Yeah, great. Nitrite is just NO2. Is the charge the same? Yeah, the charge is still -1. So it's almost like brothers and sisters or something where they're just a little bit different from each other. So 8 has 3 oxygens here and 8 has 2 oxygens. Let's find another pair that are like this. Let's look up sulfate and sulfite. I think they're both on here. Sulfate. What's the formula for sulfate? Find it on the right-hand side. Okay, it's SO4, 2 negative. Thank you, Cooper. SO4, 2 negative. And then let's look at its sibling over here. Sulfite. What do you notice about it? That one's the SO3, 2 minus. So we can't always say that 8 is 3 or 2 or 8 is 3 or 4, but we can always see a pattern here. The one that ends in ATE always has one more oxygen than the one that ends in ITE. So there's just a little difference between them. But that's going to be important because on the assignment today, if it says, I want you to draw sodium sulfite, and then another one says draw sodium sulfate, or give the formula for it, I'll be looking really closely to see that you've got the 3 or the 4 correctly there. So read those words really closely when you're dealing with those, and the lines are really small to see them next to each other there too. So that's our list of polyatomic ions that we see there. The same thing happens with chlorate and chlorite. All right, there's one positive polyatomic ion. What's the only positive polyatomic ion on there? Ammonium, yeah. So ammonium is the only positive one, and it's got a 1 positive charge. There's one more polyatomic ion. The list came from that yellow periodic table that you get when you take quizzes and tests. And hydroxide wasn't on there, so I added it, and then after I printed it, I realized there's one more that I wish I had added. So let's see if I can find that. We can write it on there together. This is your list here. There's a lot of space under phosphate, so this one has a 1 minus charge that I'm going to write on here, but just to have some space to write it, I'm going to put it after phosphate. This one's called acetate. Another one you may have heard before. So let's add this one here. I'm going to write it really big so it's easier for you to see, but you can just write it on a single line. Let's make some space there. Okay, it's going to be called acetate. ACETATE. Its formula is usually condensed for this class to this. C2H3O, 2 is down low, and then it's got a -1 charge. Hope you can see that there. Sometimes you will see that written as the more organic chemistry way to write it, which is CH3COOH, or CH3COO minus, I should say. People remember that one as, it looks like chaku, like sneezing or something. But this is how they would write it in an organic chemistry setting, with the separating the carbons out, so you can see that carbon structure. Same thing, just a different way to write it. It's got a 1 minus charge, and for some reason it's not on this list, and I think it's a pretty important polyatomic ion. Now there's really like 100 of these, all right? These are just the more common ones that you might see in like a high school chemistry class that we have on this list right here. So now let's try to put these into some compounds, kind of like we see that example on the board there with this sodium carbonate. And this is something you'll be doing for me as you start working on these coming up. Does anybody need more time with acetate? All right, so let's think about the format we might see for some problems that we might look at. So a question might say, find the formula for potassium and sulfite. So the name of this, potassium sulfite. Now, as soon as I see it ends in ITE or ATE, I think, oh, I need that pink list of polyatomic ions to find it. So if it said potassium sulfite, first I'm going to find potassium on the periodic table. What's the symbol for potassium anyway? It's K, yeah, so it's K. And what's its charge? Yeah, +1. All right, so there's potassium. And then for sulfite, I'm just going to, it ends in ITE, so that means I need my pink list. We just looked it up a second ago, but one more time. What is the formula for sulfite? SO3, and then what's its charge? It's -2. -2 or 2 minus. Okay, right now, does that add up to 0 charge? No. Do I need another potassium or another sulfite? Yeah, I need another potassium there. So if I put another potassium on there, oh, great. Now it's balanced to +2 and -2, and my overall formula is just going to be K2SO3. And that would be potassium sulfite. It's very important that you keep up with your capital letters when you do this. So the K is capital, the S is capital, the O is capital because it's a different element. Sometimes people want to do something like this for some of these and give me a lowercase o, but that wouldn't be right because there is no element SO yet. But if you did a different combination, you might accidentally act like that's a separate element there. So there's 3 different elements here. That's how I know for sure there's a polyatomic ion involved. If you have more than 2 elements, 3 or more elements, you know you have a polyatomic ion in your compound. All right, so there's potassium sulfite. If you had another question next door to that and it had said, if it had said this instead, potassium sulfide, if it ends in IDE, is sulfide with an IDE, is it on the pink list?
Yeah.
Sulfide ID, as in dog, E?
Yes.
Oh, sulfide, yeah, it is on here actually. Is it a polyatomic ion?
No.
It's not a polyatomic ion, is it? Yeah, that one is on the pink list. So we're going to go with K plus. I guess it's on there to make it not confusing. So then we put the S here. This is just like what we did yesterday. So sometimes, this one is on the pink list, but sometimes if it ends in IDE, you would want to just look it up on the periodic table as well. Sulfur is in group 16. It's got that 2 minus charge. Put that together with the 2 potassiums here, K plus, and then we just end up, just like yesterday, K2S. Not a polyatomic ion involved in here. Same idea there with any of those elements from yesterday. They put sulfide and oxide on here to kind of distinguish those two. If it just said phosphide, IDE phosphide, it's not on the pink list, so we find it on the periodic table. So most of the time when they end in IDE, there's probably not a polyatomic, but there are a couple of polyatomic ions that do. Makes things a little complicated, that do end in IDE. Like peroxide is on there and hydroxide is on here too. So occasionally even a polyatomic can end in IDE, but most of the time, there goes my screen. If it ends in IDE, there's a good chance you don't have a polyatomic ion involved there. Get this back up. All right, let's try another example here. Let's try magnesium nitrate. Magnesium and nitrate. All right, what's the symbol for magnesium? Mg. Is that what you're going to say, Gwenny? What were you going to say? Yeah, you can. Okay. Magnesium. What's magnesium's charge? What is magnesium's charge? +2. So let's get that on there. There we go. Okay, now nitrate. So I need you to find nitrate for me. Let's What's nitrate going to be? NO3, and the charge is -1. Okay, so if we put these together, what do I need more? Do I need another magnesium or another nitrate? Nitrate, okay. So I have more than one polyatomic ion this time. We see that adds up to 0. No problem so far. Now I need to come up with a chemical formula. So if you're like, okay, I get this, no problem. Just in case, I want to make sure you know how to write a chemical formula for this. So the chemical formula would be Mg. Oh, over here, Cameron. So then we got to have another nitrate. We have to have 2 nitrates. That's a great idea. If it were like balancing chemical reactions, that's what you would do. And sometimes there's a reason, like in AP chemistry, we start to do stuff like that sometimes with the polyatomics. Since I want to show that it's all bonded together as one cluster, I'm going to go the opposite with this one. I'm going to use parentheses here, and I'm going to say NO3 in parentheses, and then put the 2 outside of the parentheses. So when you have more than one polyatomic ion, you put it in parentheses, and then however many of them there are, you have a subscript outside of the parentheses to show that. The 3 inside the parentheses, that one is part of nitrate's identity. That's the same 3 that we would have had right there. So the 3 inside the parentheses sticks around because that's part of nitrate's identity. And the 2 outside the parentheses means that there's 2 of the nitrates. And also, just like we did yesterday, did I write any plus or minus? Did I write any plus or minus signs in my final chemical formula? No. Even though we know nitrate is -1, it's understood that when you write the chemical formula, you just leave it out there. All right, let's do one more with ammonium. So let's try, what if you had to do ammonium phosphide? Okay, you found ammonium, good. It's NH4 plus. And then what about phosphide? NH4 plus, I heard. What's phosphide? Good. Phosphide's -3. It's just phosphorus, so it's just P here. And then, Marissa, how did you know it's -3? On that periodic table. It's in group 15 over there, so it's -3. So how would I put together ammonium and phosphide? Give me a 0 charge. 2 more ammoniums. Try to fit them all on the screen here. Let's put this one over here. So I like to show the circles are touching. You don't actually have to draw the circle model every time for these today. You can go straight to the formula for some of them. But there we have the 3 ammoniums and the 1 phosphide. Does that add up to 0? Yep, +3 and -3. So then for my chemical formula, how am I going to say that I have 3 ammoniums? Big parentheses, you got it. NH4 in parentheses. Little 3 outside there, and then you can have the capital P for phosphorus. Okay, so that's how you're going to deal with these polyatomic ions. Somebody was running around out there, Gwenny. So like in number 11, it says the element or polyatomic cation. What was the charge of cations again? They were positive. So what would be my cation in this element, the lithium or the nitrate? The lithium. It's almost always the first one. So lithium is going to be that one. So I could just put Li, and then I can look up its charge from the periodic table. It's in group 1, so I'll put +1 there. So it's like a modified version of drawing them out where you're just really focusing on those charges. And then what's the anion for this particular element, this particular compound? Nitrate, thank you, nitrate. So we looked that up on our pink sheet. Okay, what's the formula including the charge of nitrate? NO3 minus 1. Now, one's plus 1 and one's minus 1. How are those going to come together? One of each, and that adds up to 0. So you can go straight to LiNO3. Do I need any parentheses this time? No. If you just have one of the nitrates, you don't use parentheses around it. It's just kind of understood there. And you still have that 3. That 3 doesn't mean you have 3 nitrates. That 3 is just part of nitrates identity in the first place. If you wanted to show me you had 3 of the nitrates, you have to use parentheses there. So that's how you'll do the back page of this. So I want you to work on this for a while. Once we all get finished or close to finished, I wanted to do a quiz live with that peak list and use the peak list just to get familiar with those polyatomic ions a little bit more. But I'll give you a little bit of time to work on this for a while. If you have questions, just ask. If you finish really fast, I want to come and check these like I did yesterday to make sure you're doing